Hello. Here we introduce the course Electromagnetism on NPTEL. The duration of the course is 12 weeks. I am the instructor of this course. My name is Nirmal Ganguly. I am an assistant professor in physics at IISER Bhopal, that is Indian Institute of Science, Education and Research, Bhopal. Electromagnetism is a topic that almost every undergraduate student of science, technology, engineering and mathematics learn in their first or second year of study. This topic is immensely important for studying higher level physics and electrical engineering. Further, preparation of competitive exams like GATE remain incomplete without being able to apply the principles of electromagnetism. Most of the science students in their 12th standard study some of electromagnetism without much of mathematical rigor. In this course, we will develop the principles of electromagnetism with appropriate mathematical rigor. In order to do so, we will first introduce the necessary mathematical tools. Why should one take this course? In this course, we will develop the topics in a student-friendly way. Besides helping the students understand the principles of electromagnetism, they are expected to be able to apply their knowledge in solving problems related to the topic and develop new theory based on the content of the course. Moreover, this course is expected to be a fun learning activity with focus on honing the scientific temper.
Okay, so we will briefly discuss about the content of the course Electromagnetism. This course is unique. It's different from the other online available courses on electromagnetism by the way of introduction of mathematical background in this. Whatever is required for electromagnetism, whatever mathematical background we need, we will develop that first and then we will go on to understanding electromagnetism. So we will start with vector algebra that many of you already know. So we will go quick over it. Then we will introduce vector calculus. The differential vector calculus includes gradient, divergence and curl. The integral part of vector calculus includes line, surface and volume integral. And then we will see two interesting vector calculus theorems, namely the divergence and the Stokes theorem. Then we will move on to curvilinear coordinate systems. Because in electrostatics and magnetostatics and electrodynamics, of course, we will find few systems where the symmetry is spherical or cylindrical. That's why curvilinear coordinate system is particularly important for those handling those kind of problems. So we will focus mainly on spherical and cylindrical coordinate system. We will learn about line, surface and volume elements and how to integrate over those coordinate systems. Then we will also introduce the Dirac delta function that will be useful later on. Then comes electrostatics. Electrostatics, of course, starts with Coulomb's law. Then we will develop Gauss' law from Coulomb's law. We will learn its differential and integral forms and its applications. We will develop electric potential. We will discuss Poisson and Laplace equation and the method of images. Then we will try to analyze the energy of a charge distribution. We will then move on to the field and potential due to a dipole. After that, we will develop the concept of polarization in dielectrics. We will discuss about linear dielectrics and force on dielectrics. After having done that, we will move on to magnetostatics, where we will start with the motion of a charged particle in electric and magnetic fields. We will learn about electric currents, analyze line, surface and volume currents. Electrical conductivity and Ohm's law will be discussed. Equation of continuity and energy dissipation will be discussed in this course. Then we will move on to Biot-Savart law. We will discuss about divergence and curl of the magnetic field. We will develop Ampere's law in its differential and integral form. We will develop a vector potential to describe the magnetic field. That would be something very interesting. And Finally, the magnetic dipoles, magnetization in material, and diapara and ferromagnetism will be discussed in the context of magnetostatics. Then, the last part of this course is electrodynamics, where we are going to discuss electromagnetic induction, and from that we will develop the notion of motional electromotive force and also develop Faraday's law. Then, inductance and energy in a magnetic field will be discussed. We will develop the notion of the displacement current following the approach of Maxwell, and hence we will write down the Maxwell's equation. After writing down the Maxwell's equation, we will try to understand electrodynamics within the framework of Maxwell's equations, and from that we will develop an outlook about electrodynamics.
The only prerequisite for this course is the knowledge of calculus. I hope you will enjoy this course. I am looking forward to interacting with you during the course. Thank you.